Now I'm going to go through the instrumentation. We have basically 3 or 4 types of instrumentation to understand the thermodynamics. We need to measure the power that goes to the compressor, and to measure the power we need to measure the voltage and the currents. So the voltage and the currents, this is a voltmeter, 119.47 volts. And the current that goes into the compressor is measured by an ammeter here, in amps. So if you multiply the amps here that you'll see when we turn on the cycle times the voltage, that gives you the power here. Also, we measure the current that goes to the fans from here and here. This is the 2 fans that we have. This is the evaporator fan, and this is the condenser fan. So that's kind of first set of instruments. Second set of instruments would be the temperatures, because we need to know the state of the fluid at any point, and to need the state of the fluid, we need to measure temperatures and we need to measure pressures. The pressures are 4 points. So we have pressure point number 1, P1, right here. We have point number 2 is right there. So from P1 is going to drop to P2. And then from P2 is going to go down to P3. So P2 and P3 will be very low. And then P4 is going to increase the pressure again. So you got 4 points. 1, 2, 3, 4. So we're done with the pressures. Now we're going to talk about the temperatures. The temperatures, we have a number of points that do not correspond exactly to the 4 points on the cycle. So you have to be careful how you translate every temperature to temperatures on the cycle. So if you look at it, let's see if we can find the temperatures starting from T1. So let's see, it starts from T2. We'll get to T1. So T2 is right here. So T2, this is the temperature corresponds to P2. And then the temperature T3 is buried right behind this glob. So this is T3. So at the bottom of the evaporator. And then if you go down here, you go down here, you see the temperature T4 is actually at the inlet of the compressor. And then if you go up here, then we will see this is T5 is at the exit. I believe it's right here. So it's hiding right here at the exit. And then we continue to go to the temperature T6. This is at the entrance to the condenser, and that continues. And then it goes to T1, which is actually at the bottom of the condenser. And then we have temperature T7, which is the cool air temperature up here. So this is temperature T7. And temperature T8, which was for the ambient air temperature. And then temperature T10, which is for the hot air temperature, and we don't have T9. And this, you can find the temperatures by turning on the power on the digital thermometer. This is on right there. And this is a selector for each thermometer, thermocouple. So if you make this to, for example, select 6, this will be the temperature that you measure at T6. So your job will be to record the temperatures by just selecting them here. All right, so to summarize, what you're going to measure will be, you're going to measure the flow rate, you're going to measure the 3 currents, you're going to measure the voltage, you're going to measure 7 or 8 temperatures, and you're going to measure 4 pressures. So you're going to have to make a big table, and this table you have case number 1, and you get all of these measurements in there. And then you have to divide your experiment to 3 sets. So set number 1 will be for the pressure-controlled expander. Set number 2 will be for the capillary tube expander. Set number 3 will be for the thermally controlled expander. And the steps are described in the manual. Now, word of caution is very important, because this system cannot go to too low of a pressure. Otherwise, everything will be the air is going to ingress into the system. Cannot go to very high pressure, otherwise we'll have mechanical damage. So to control that, we have two set trip points, high pressure, low cutoff, and low pressure cutoff, and those make sure that we don't have any problems. The problem for you, however, is that if you somehow allow the system pressure to go very high, then we'll have the trip come in, and then you'll have cutoff, and the system is going to shut down. That's the problem, because you're going to have to wait for probably an hour until you kind of restart it. So the way that you do it is that you have to be careful not to make sure that there's enough flow, balanced flow, when you switch from one valve to another. For example, if I'm switching from this valve, the pressure-controlled valve, to the capillary tube valve, look at the way that I'm going to do it here, just like driving a car. So what you're going to do, this is fully open right here, and this is fully closed, this is fully closed. Now I'm going to make sure that there's enough fluid, then I'm going to open this first, a little bit. And then as I'm opening this, I'm going to close this at the same time, slowly, and I make sure that I open this a little bit more. And I do that in sync, then the fluid is transitioned kind of neatly from going through here to going through here. And the system is sort of stable. At the same time, to make sure that I don't have a problem, then I must make the bypass that I talked about before. So I have to open that to allow bypass here, so I don't have any blockage in here. Once the system runs for a minute or two or three or four and it's stable, then I'm allowed now to close open this, or close this here, and let the flow go through the flow meter and take my measurement, and I'm ready to kind of continue the second set of experiments. All right, that's it for now. Thanks. Okay, so now I think the last part of this explanation is we're going to show you how we turn on the system. There's a power cord in the back. It has to be plugged in. So the power cord is plugged in already for you. And now in the front, as you will see, we have switches, one here for the compressor, on and off, and two for the fans. This is the evaporator fan. It has off position and two other positions, low speed and high speed. Same thing for the compressor fan, has off position, low speed, and high speed. Okay? So the way that it works is that we do not turn on the compressor first. We turn on the fans because the fans can run whatever they want to do. So let's say that we have high speed here, high speed here. So I'm getting air flowing from here, air flowing from here, but I haven't turned on the compressor yet. Now I'm ready to turn on the compressor. Compressor on. You can see now that the system, there's a noisy system, and the pressures are kind of trying to adjust themselves. This is, if you look at the pressure now on the compressor, you'll see the pressure on the compressor and the intake is coming down. And that's kind of the first set that and if you look at the fluid is trying to adjust itself here from to a liquid. This is vapor, and so it's all, and here's two-phase, you can see two-phase. So all of this is just the startup process is very transient, and it takes a few minutes until the system settles down. If you can see now that the pressure up here is like 20-some, and the pressure at the intake of the compressor is now down to about 12 or 13. And the compressor has done work, and it increases the pressure to about 120. So it's doing the right thing. But it's still kind of in a transient state, and it's going down. But, you know, so now if you just put your hand, you'll see that you feel that it's cold here, and it starts to warm up here. Then now we can do the first set of experiments by, I want to lower this, say, to 2. So what I do is I open it, and as I just open the flow area, then I reduce the pressure. As you can see, it's going to go down. So I'm going to do it, but I have to do it slowly, because if I go too fast, then we can get negative pressure, which is not very good. So I have to do it kind of slowly. In the beginning, I want to just knock it down a little bit faster, And then now I have to be careful because this is about 5. So I have to go down 1 step and I look. Okay, still 5. Another step and I look, still 5. And then another step and I'm about there. So this will be my first experiment, about 2. And the system is, I give it about 2 or 3 minutes, go to equilibrium, and then you take all of your readings and you're done with 1 experiment on that set of 3 that we talked about, and that will be for the first valve. Then the next set you switch, next set you switch, and you're done with the experiment.